Yes, welcome children. Welcome to another chemistry class. In this class, we will be discussing some beautiful questions from the chapter Solutions. That is the second chapter of 11th standard topic. Ready? Let's start. This is the first question we have. What is the mole fraction of solute in a 1 molar aqueous solution? You know what is the meaning of 1 molar aqueous solution? 1 molar means 1 mole solute in 1 kilogram solvent, that is water. And we want to know the mole fraction. When we take mole fraction of solute is equal to number of moles of solute by number of moles of solvent plus number of moles of solute. Number of moles of solute is 1 given in the question, divided by number of moles of solvent. It is 1 kilogram water, so it is 1000 gram water divided by 18 plus 1 mole of solute. So number of moles of solute is 1. Number of moles of solvent is 1 kg water, 1000 gram water. So what is the number of moles? 1000 divided by molar mass. So the calculation will be 1 by 55.5 plus 1, that is 1 by 56.5. See, 1000 by 18, all of you know that figure, 55.5. So it is close to 1 by 60 means 0.016, slightly greater than that, 0.016. Suppose I am taking this as 1 by 60. It is 0.016 and the value is slightly greater than that. Second choice is the correct answer. Correct answer is second choice. Is it clear? Look at that once again. 1 mole solute in 1 kilogram solvent. 1 kilogram solvent means 1000 gram water. And mole fraction is number of moles of solute by total number of moles, and hence you get the answer. Option 2. Next question. Second question. The Van 't Hoff factor for a dilute solution of strong electrolyte, barium hydroxide. Barium hydroxide, BaOH twice. This is barium hydroxide, right? And barium hydroxide, how many ions you get? You are getting Ba2 plus and 2OH minus. That means a total of 3 ions you will get. 1 cation and 2 anion. 3 ions you get. And I am sure all of you understand, for a strong electrolyte dilute solution, it is alpha equal to 100%, and at that situation, N is equal to I. N is equal to I. When the degree of dissociation is 100%, alpha is 100%, N is equal to I. You have been taught in the classes, alpha is equal to I minus 1 by N minus 1. And when alpha is 1, that is 100%, alpha equal to 1. That means you are getting 1 equal to I minus 1 by N minus 1. That is N is equal to I. That is N is equal to 3 here. That means I aanu chodichirikkunnathu. I will be the same figure. Second choice is the correct answer. This will be the correct answer. 3. So when alpha is 100%, N is equal to I. What is N here? Barium hydroxide. 1 cation, 2 anion, a total 3 particles. Is it clear? Next question. Which of the following is incorrect for ideal solution? Incorrect for ideal solution. For ideal solution, delta P, that is the partial pressure observed minus calculated is equal to 0. That is a true statement. There is no positive deviation. Suppose it is positive deviation, vapor pressure will increase. Suppose it is negative deviation, vapor pressure will decrease. For an ideal solution, there is no change in the pressure. It will be as per the theoretical value. What is the theoretical value? Raoult's law. It will be as per the Raoult's law. Ideal solutions obeys Raoult's law. Right? What about the second one? Delta G mixing equal to 0. That is the wrong statement. And that is the answer. Delta G mixing 0 means it is equilibrium. It is not delta G mixing 0, it is delta G mixing negative. Because the mixing process spontaneously happening, and all spontaneous process delta G is what? Negative. Delta G 0 means what? It's equilibrium. Is it clear? So delta G equal to 0 is the wrong statement, while enthalpy, internal energy, all will be 0. So for an ideal solution, number 1 obeys Raoult's law, delta H mixing 0, delta V mixing 0, molecular interactions before and after mixing remain almost the same. Okay, next. Which of the following dependent on temperature? Molality, independent on temperature. Molarity is the answer. Molarity depends on temperature because it carries volume term. Molarity depends on temperature because it carries volume term. Okay. And how that influences? Molarity is equal to number of moles by volume in liter. Number of moles by volume in liter. As the temperature increases, volume increases, molarity decreases. That is the usual scenario. When the temperature increases, usually we can say molarity decreases. Is it clear? But I would like to remind you one question, which old question. And the question is like that. The temperature of an aqueous solution, the molarity of an aqueous solution with the rise in temperature. The molarity of an aqueous solution with the rise in temperature. See, according to the context, when the temperature increases, volume increases, molarity decreases. The answer is molarity decreases, but the reported answer is, I repeat the question, the molarity of an aqueous solution with a rise in temperature. The reported answer is may increase or decrease. Try to think about that logic, why it is so. Try to think about. Anyway, as far as our question is concerned, the answer is molarity. Molarity is temperature dependent as it carry a volume term. Any concentration term with a volume term, it will be temperature dependent. Okay, think about the question which I have put forwarded. What is the question? What happens to the molarity of an aqueous solution with the rise in temperature? I am reporting the answer also. May increase or decrease. That is the correct answer. Think why and how. Okay, next question. If molality of the dilute solution is doubled, the value of molal depression constant will be. Molal depression constant is a constant. Molal depression constant is a constant. So it remains unchanged. By changing the molarity of solution, Kf, Kb won't change. Kf, Kb are characteristic of the solvent. And you know how it is related. RTB square by 1000 LV or RTB square M by 1000 delta H. You have learned that. So it is depending on the nature of the solvent, not on the concentration of the solution. And the answer is option 4, unchanged. For an ideal solution, the correct option is, delta V mixing not equal to 0. That is an incorrect option. Delta V mixing is equal to 0. Delta H mixing 0. That is a correct option. And that remained the answer. Delta G mixing 0. Few minutes back we have commented. It is wrong. Delta G mixing is negative. Delta S mixing 0. That is wrong. What about delta S mixing? It is not 0. What about delta S mixing? When you mix, entropy increases. Delta S mixing is positive during the formation of a solution. So all the statements are false except the second one. Okay, next question. The mixture that forms maximum boiling azeotrope. Maximum boiling azeotrope means positive deviation or negative deviation. Maximum boiling, higher boiling azeotrope. That means vapor pressure is low. That means a negative deviation. So which of the following is negative deviation? Ethanol water, positive deviation. Acetone carbon disulfide, positive deviation. Heptane octane, no deviation. Ideal solution. And the answer is fourth one. Water with nitric acid is the one showing negative deviation. Water with nitric acid is the answer. And you see some examples. It's few examples are there in the NCRT. Some more examples you can see. Acetone carbon disulfide showing positive deviation. Acetone carbon disulfide. Acetone benzene. CCl4 toluene or chloroform. Methyl alcohol water. Acetone ethanol. Ethanol water. Try to go through similar examples for ideal solution, positive deviation, negative deviation, etc. Few examples for negative deviation you can find. Acetone aniline, acetone chloroform, methanol acetic acid, water nitric acid. That is the answer here. Chloroform diethyl ether, water with HCl, acetic acid with pyridine, chloroform with benzene. In all these cases, the attraction after mixing will decrease. The attraction after mixing will increase. Therefore, the vapor pressure will decrease and therefore the boiling point will increase. And they form higher boiling azeotropes. So the components which show negative deviation will show higher boiling azeotrope, maximum boiling azeotrope, while the one positive deviation will show lower boiling azeotrope. I'm sure you know what is azeotrope. Azeotrope means constant boiling mixtures. It is performed by non-ideal solution with the positive and negative deviation, and there are two types of azeotropes as all of you know. Okay, next question. The mixture which shows positive deviation from Raoult's law. Benzene toluene, that forms ideal solution. Benzene toluene forms ideal solution. Acetone chloroform. Isn't that the answer? Just now we had one. We want positive deviation. Acetone chloroform. Acetone chloroform is negative deviation. Chloroethane, bromoethane. You see, these two molecules are identical. They'll form ideal solution. Chloroethane, bromoethane. They are identical molecules. They will form ideal solution. Acetone chloroform. That will form negative deviation. I'm sure this is given in the NCRT example also. After mixing, the oxygen of acetone makes a hydrogen bonding with the hydrogen of chloroform. It forms a negative deviation. You see what happens in acetone chloroform mixture? You might have seen that in the textbook. CH3, CO, CH3 will make a hydrogen bonding with the hydrogen of chloroform. So after mixing, the molecular attraction increases. So what happens? That forms the vapor pressure decreases. That forms a negative deviation solution. So quite naturally, the answer is ethanol acetone. Answer is ethanol acetone. And that too was commented here, ethanol acetone. You see the example here. So try to capture and go through as many examples as possible concerned to this particular example based question. Okay, next one. Freezing point depression constant Kf of benzene തന്നിട്ടുണ്ട്. The freezing point depression for the solution of molality 0.078 molal containing non-electrolyte solute in benzene is. We want to know the freezing point depression. That is what asked. Very simple, direct question. Delta TF is equal to I into KF into M. Since it is a non-electrolyte, you can take I equal to 1 and substitute I, KF and molality. You get your answer 0.399. That is close to 0.4. 0.4. Which one? Second choice is the correct answer. So just substitute in the equation. Delta TF is equal to I into KF into M. Okay, next. Desalination of seawater on a commercial basis is based on reverse osmosis. You have learned that reverse osmosis. By reverse osmosis, you can see the pure solvent water molecules are migrating to the opposite side. By applying a pressure more than osmotic pressure on the solution side, there will be migration of solvent molecules from the solution outward. Please refer the textbook with the diagrams given, reverse osmosis and desalination principles. Okay, RO systems. Next. The vapor pressure P1 and P2 of liquid are related to the corresponding temperature T1 and T2. The equation not in the syllabus but as an additional point of information, and sometimes in certain examinations that kind of formula they ask at least as a formula based question. So it is better to learn that very famous equation, Clausius-Clapeyron equation. This is Clausius-Clapeyron equation. That is log P2 by P1 equal to delta H by 2.303 R T2 minus T1 by T1 T2 or 1 by T1 minus 1 by T2. Option A is the correct answer. Just note down the equation and learn that equation. At times in certain examination, it may be required at least as a formula based question. Okay, there can be a problem, but remote possibility only. Next question. Calculate Kb value of benzene from the data. See, this is what the point few minutes back I was commenting. Kb is equal to RTB square M by 1000 delta HV. The formula available in the textbook. Formula available in the textbook. Go through that. Simple substitution of the given data, and what do you get as the answer? Kb is equal to RTB square M by 1000 delta H vaporization. R value known. TB given, boiling point is given 80 degrees Celsius, that is 353 Kelvin square, into molar mass of benzene 78 divided by 1000 into delta H vaporization 30.8 kilojoule, 30.8 into 10 power 3 joule. And you get the kV value 2.62. Option C, the correct answer, 2.62. A question of definite possibility, because that formula we are learning in the NCERT. Even it can be such an application, the formula is not so given in the textbook. It may be like this: KB is equal to RTB square divided by 1000 LV, latent heat of vaporization. It can be like this also, latent heat of vaporization. What is latent heat of vaporization? This is equal to, latent heat of vaporization will be equal to delta EH vaporization divided by molar mass. And from this equation actually you are getting this. So when you substitute delta H by molar mass will go to top. That's all. So that equation also keep it in mind. Next one. 0.2 molar aqueous solution of a weak electrolyte AB is 30% ionized. The solution will freeze at. So molality given, type of electrolyte given, alpha given. The solution will freeze at. Find out delta TF. Find out delta TF. Once you get depression in freezing point, you can get the new freezing point. What all things are required? Delta TF is equal to I into KF into M. KF given, M given. What is I? What is I? I you can evaluate like this. Alpha is equal to I minus 1 by N minus 1. It is AB type electrolyte. For AB type electrolyte, N is equal to 2. So it will be I minus 1 by 2 minus 1, that is 1. So alpha is equal to I minus 1, and therefore I is equal to alpha plus 1. Alpha given 30% plus 1, it is 1.3. You get I. Once you get I, you can get delta TF. Delta TF is equal to I into KF into M. Now you have I, you have KF, and you have M. M is given in the question, 0.2. I is available. So it is 1.3 into 1.85 into 0.2. And you get delta TF. Once you get delta TF, you get your answer. What is the answer? I is equal to 1.3. I is equal to 1.3. Delta TF is equal to 1.3, 1.85, 0.2, 0.481. 0.481. Therefore, the new temperature, freezing point will be minus 0.481. The old freezing point of solvent, 0. The freezing point of solution, depression in freezing point, 0.481. So what is the new freezing point? The freezing point of solvent minus freezing point of solution is delta TF. Therefore, freezing point of solution will be freezing point of solvent minus delta TF. You are getting the answer minus 0.481, option C. So water freezes at 0 degree. The solution freezes at minus 0.481 degree. So what is the depression in freezing point? 0.481. Okay, next. In the diagram, curve 1 is applicable to pure solvent and 2 applicable to a solution with a non-volatile solute. P external pressure, then the correct statement. P is the boiling point of solvent. P is the boiling point of solvent. True. This is the boiling point of solvent because this is solvent. So this is the boiling point of solvent. True. Q is the boiling point of solution. True. Q this is solution. So Q is the boiling point of solution. You know what is boiling point? Boiling point is the temperature at which vapor pressure of liquid becomes equal to external pressure. So vapor pressure of solvent becomes equal to external pressure, and that is boiling point. Vapor pressure of solution becomes equal to external pressure, that is the boiling point. Boiling point of solution is always more than that of solvent. Perfect answer. Answer is all these. Option D. Because it is a non-volatile solute. See, non-volatile solute. When you add a non-volatile solute, there will be colligative property. There will be depression in freezing. There will be lowering of vapor pressure. When the vapor pressure lowers, boiling point increases. There will be elevation in boiling point. Okay. D is the correct answer. Next. The above graph is applicable to an aqueous solution of non-volatile solute like glucose. In the graph, Y is delta TF and X is molality. Slope is KF. True. True. Because delta TF is equal to KF into molality. So if you take this along the y-axis, this along the x-axis, this will be the slope. And starting from the origin, that's a true statement. If y is delta TB, x is molality, so this is also true. See, if this is true, this is also true. Because it is delta TB is equal to KB into M. If you take this along the y-axis, this along the x-axis, this will be the slope. Y equal to mx plus c. And the y-intercept is 0. So it will start from the origin point. If y is osmotic pressure, x is the molarity, slope of the line is positive. Osmotic pressure equation, pi is equal to CRT. If this taken along y-axis, if this taken along y-axis, this taken along x-axis, this will be m. Yes, that is positive. And the slope will be RT. Slope will be RT. So all the statements are true. All the statements are true. Okay, answer is option D. Right? Next question. Option D. A 5% solution of glucose, molar mass 180, isotonic with a 2.5% solution of substance X at the same temperature, molar mass of X is. See, isotonic means the same osmotic pressure. Two solutions having same osmotic pressure. That is called a isotonic solution. Here we have a solution of glucose with the substance X. What is the molar mass? Isotonic solution, it is equimolal. How it is equimolal? Isotonic means pi 1 is equal to pi 2. That is C1 RT is equal to C2 RT. That is C1 equal to C2. That is N1 by V is equal to N2 by V, assuming same volume. That is N1 is equal to N2. That is W1 by M1 equal to W2 by M2. W1, you can take mass percentage, mass volume percentage, 5% given. So W1 we are taking 5. And molar mass of glucose 180 M1. And W2 it is 2.5. And what is the molar mass of that substance? Absolutely no calculation required. 5, 180, 2.5, this will be 90. The answer is 90, option A. Option A is the correct answer. So what is isotonic means? Isotonic means same osmotic pressure. That means pi 1 is equal to pi 2. That is C1 RT is equal to C2 RT. That is C1 is equal to C2. N1 by V equal to N2 by V. Why we take the same volume? Let us assume 5% mass by volume. 2.5% mass by volume. So both are having same volume 100 ml. Assume both having same volume 100 ml. So N1 is equal to N2. N1 is equal to N2. That is W1 by M1 equal to W2 by M2. This is given, this is given, this is known. What is this? Clear? Next question. 6 gram urea dissolved in 90 gram water. Relative lowering of vapor pressure is equal to. Relative lowering of vapor pressure is delta P by P0. That is equal to XB. That is equal to NB by NA plus NB. That is WB by MB divided by WA by MA plus WB by MB. All data available. 6 gram urea dissolved in 90 gram water. So mass of urea available, molar mass of urea known, mass of water given and molar mass of water given. You can find out the answer. Direct substitution, nothing in it. So how much you will get? How much you will get? Number of moles of urea. Number of moles of urea 6 by 60, 0.1. Number of moles of water 90 by 18, 5. Therefore, mole fraction 0.1 by 5 plus 0.1, that is 0.1 by 5 approximately. This is negligible. So you are getting 0.02. That is mole fraction of urea, and that is nothing but delta P by P0, that is lowering of vapor pressure. Option A, the correct answer. Okay, right? Next. Benzene and ethylene chloride form ideal solution. So vapor pressure of benzene given, vapor pressure ethylene chloride given, they form ideal solution. Total pressure made by dissolving 2 mole benzene, 3 mole ethylene chloride will be. Another question applying direct possibility of Raoult's law. How to apply that? How to apply that? P total is equal to P1 plus P2. P total is equal to P1 plus P2. That is equal to P01 X1 plus P02 X2. What is P01? 268. What is X1? What is X1? X1, it is 2 mole benzene, 3 mole ethylene chloride. So it is 2 out of 5. 2 out of 5. 2 mole benzene. So what is the mole fraction of benzene? 2 out of total number of moles. 2 plus 3, 5. Plus, what about ethylene chloride? 236. 236 into 3 by 5. That gives you the answer. This will give you the answer. Right? So how much it arrives? How much it arrives? 268 into 0.4. This is 0.4. 268 into 0.4 plus 236 into 0.6. So 268.4 plus 236.6 will take you to the answer 248.8. Option B. You will get option B, 248 as the correct answer. Right? Next, direct application of Raoult's law. Direct application of Raoult's law. Next, match the following. Constant boiling mixture, that is azeotrope 1B. 1B, you get your answer. 1B, you get your answer because constant boiling mixture is azeotrope. Azeotrope is a 2D delta TB by M. That is KB. That is correct. 3A mass, molar mass calculated by observed. Yes, that is Van Dove factor. 4C, copper ferrocyanide. Copper ferrocyanide is an artificial semi-permeable membrane. So all are matching to the extent required. But simply by checking one, we get our answer. Okay, next. Answer is option B. B. Next. Maximum freezing point depression is observed when dash is used as the solvent. It is camphor. Camphor having, we are talking about maximum freezing point depression. See, camphor having very high value of Kb, Kf, etc. See, so many solvents, the Kb, Kf values are given in the NCERT. But I remember there is no camphor given there. Please understand and incorporate this data with that table. Camphor will have very high value of Kb and Kf. When Kb, Kf value of a solvent is very high, the observed delta Tf, delta Tb will be very high. Elevation in boiling point will be very high. Colligative property will be very high. Okay. And the answer is camphor. It is camphor having Kf value 40. Having Kf value 40. Kb value also relatively high compared to other solvents. Okay. Try to incorporate this data along with that table in the textbook, where I believe camphor is not given, while others are given. Next. Vapor pressure of benzene, toluene are 500, 200 respectively. The composition of vapor phase Y benzene, Y toluene of a solution containing 2 mole benzene and 3 mole toluene will be. So we want to find the ratio of composition in the vapor phase. Ratio of composition in the vapor phase. How to get that? Apply Dalton's law, apply Raoult's law. Apply Dalton's law, apply Raoult's law. How you get Y1 or Y? What is the equation for Y? You know, PA is equal to YA into P total. Therefore, YA is equal to PA by P total. Keep this in your mind. Keep this in your mind. Therefore, Y1 is equal to P1 by P total. Y2 is equal to P2 by P total. How to get P total? How to get P total? P total you can get P total is equal to P1 plus P2. That is P01 x1 plus P02 x2. P01 x1 plus P02 x2. What is P01 given? 500. What is x1? 2 by 5. How it is 2 by 5? 2 mole benzene, 3 mole toluene. So it is 2 by 2 plus 3. So you are getting P1. Then you are getting P2. P1 plus P2. That is P total. So Y1 will be P1. P1 divided by P total. You are getting 0.625. And Y2. P2 by P total. You are getting 0.375. Right? And that ratio 0.625, 0.375 is nothing but 5:3 ratio. It is 5:3 ratio. You can easily assume 5:3 ratio. Option A, the correct answer. 0.625 is to 0.375. That is 5:3 ratio. Right? Next one. So find out P total. Find out P1, P2, you get your answer. Find out P1, P2, find out P total, you get your answer. Okay? Next. 0.004 molar solution sodium sulfate is isotonic with a 0.01 molar glucose solution. degree of dissociation of sodium sulfate is. How to find the degree of dissociation? Degree of dissociation alpha is equal to I minus 1 by N minus 1. What is N? Sodium sulfate. N is equal to 3. N is equal to 3. 2 sodium and 1 sulfate. 2 cation, 1 anion. So it is I minus 1 by 3 minus 1. So it is 2. Right? Now you can get degree of dissociation once you get I factor. I factor you can easily evaluate, right? It is given pi 1 is equal to pi 2. Pi 1 is equal to pi 2. That is I1 C1 RT is equal to I2 C2 RT. That is I1 C1 is equal to I2 C2. So I1 into C1 0.004 is equal to I2. We are talking about glucose. For glucose, I value is 1. So it is 1 into C2 0.01. So you are getting I is equal to 0.01 by 0.004. Once you get I, you get alpha. Once you get I, you get alpha. I is equal to 0.01 divided by 0.004. That is 10 by 4. How much? 2.5. That is I value. I value you will get 2.5. I value you will get 2.5. Therefore alpha is 2.5 minus 1 divided by 2. That is 1.5 by 2, 0.75. Alpha is 75%. Option C. I value you will get 2.5. Therefore alpha will be this one. I minus 1 by 2. 2.5 minus 1. 1.5 by 2. 0.75. That is 75%. Option C. I think it is okay. Or straight away you can take it like this. I is equal to 1 plus 2 alpha. That is also okay. I is equal to 1 plus 2 alpha. 1 minus alpha plus 2 alpha plus alpha. That is 1 plus 2 alpha. Next. Phenol dimerizes in benzene and has a Van der factor 0.54. Degree of association of phenol is. What is equation for degree of association? Degree of association alpha is equal to 1 minus I by 1 minus 1 by N. Degree of association alpha is equal to 1 minus I by 1 minus 1 by N. Where N is 2 here. Because it is dimerizing. Dimerizing means N is equal to 2. So what do you get? 1 minus I by 1 minus 1 by 2. We want to find alpha. Van der factor given 0.54 over. So it is 1 minus 0.54 divided by 1 minus 0.5. That is alpha. 1 minus 0.54 divided by 1 minus 0.5. So how much it is? Very close to 90, very close to 100, because it is going to be some 46, isn't it? 0.46 by 0.5, 0.46 by 0.5, that is 46 by 50. 46 by 50 is very close to some 95%. Option D should be the answer. Option D should be the answer. Exactly. Alpha is 0.92. One minus 0.54, that is 0.46 divided by 1 minus 0.5, 0.5. 0.46 by 0.5 means 46 by 50. That is more than 90% definitely. No need to calculate. No need to calculate. Next question. The diagram given below shows two solutions A and B of the same solute but of different molar concentration taken in two compartments of a closed vessel. This is kept in a thermostat, means constant temperature. After some time the situation has been reached. The conclusion given below. The level of solution has gone down due to evaporation. Not clear statement. Level of solution has gone up due to condensation. The level of A has gone up while that of B gone down because A was more concentrated than B. That is correct. Option C is correct. Imagine this is initial. There is a clarity issue. Imagine this is initial position. You see B gone down, A come up. That can happen only when B is dilute solution. B is dilute solution. Why? When B is dilute solution, the amount of solute is low. Lowering of vapor pressure will be low. That means vapor pressure will be high. So there will be more evaporation from B. There will be more evaporation from B than A. So when you find the vapors here, the vapors are mainly from B. And now they are condensing back equally. They are condensing back equally. See, these vapors are condensing back equally. But there is more evaporation from B. Evaporation from A is less because it is more concentrated. A was more concentrated. Since A is more concentrated, there is more amount of solute particles. Colligative property is more. Colligative property more means lowering of vapor pressure is more. That means vapor pressure is low, evaporation is low. So evaporation from A is low and that from B is high and is covered with a bell jar like a dome. The vapors from B will be more available here and they are condensing equally to the compartments both. So what happens is there is a net result of matter transfer from here to here. There will be a transfer of matter net result from B to A. So what happens? The level of B will come down and the level of A will go up. Till what? Till what? Till the concentration of both becomes equal. This will happen till the concentration of both will become equal. So solvent matter evaporating from B will ultimately transfer to A. That will happen. So the correct answer is option C. The level of B has gone down while that of A gone up because A was less concentrated. Suppose A was less concentrated. Suppose A was dilute solution. It will be more evaporating. And that evaporated matter will be ultimately transferring to B. So there will be a net transfer of matter from A to B. A will come down, B will go up. What commented? The level of B gone down. That is wrong. If this is correct, this is wrong. So option D is wrong. Option C is the correct statement. Next, 25th question. The degree of dissociation alpha of a weak electrolyte related to Van der factor I by the expression. It's a repeated question, right? Alpha equal to I minus 1 by n minus 1, where n is equal to x plus y. That is the number of particles you can get from Ax By. From Ax By, you can get x A particles and y B particles. Total x plus y particles you are getting. So n is equal to x plus y. So is the answer. Which one? I think that itself we can get the answer. Alpha is equal to I minus 1 by x plus y minus 1. First choice itself. Option A itself is the correct answer. Okay, next. Twenty-sixth question. Osmotic pressure of blood is 7.658 atm at 310 Kelvin. An aqueous solution of glucose will be isotonic with the blood if its concentration weight by volume percentage is. Weight by volume percentage is. You apply in the formula. Pi is equal to CRT equal to N by VRT equal to M by M RT by V. This is what we want. This is what we want. R you know, temperature given, M you know, and pi is given. Pi given 7.65. Temperature given, R known, M value known. You can find out M by V. You can find out M by V. And that need to be taken in what? Percentage. Percentage. So here the volume, if it is liters, convert into 100 ml. That's all. So how we can do that? Pi is equal to nRT by V, WRT by V. This is what we want. This is what we want. This is what we want. So that will be equal to pi m2. Pi is equal to this. So this is equal to pi into m2 by RT. Pi into m2 by RT. Pi given, m you know, R you know, temperature given. You can get 54.1 gram per liter. W2 by V. Mass by volume. You get 54.1 gram per liter. Gram per liter. What intended is weight by volume percentage. Look at the choices. Weight by volume percentage is required. So how much in 100 ml? In 1000 ml? In 1000 ml, 54.1 gram. So in 100 ml, it will be 5.4 gram. In 1000 ml, 54.1 gram. So in 100 ml, 5.4 gram. So that is the percentage, 5.4 percentage, option A. I think it is okay. Next question. 31 gram ethylene glycol mixed with 40 gram water. Kf of water given. The solution freezes at. Repeating question. Repeating question. Find out delta TF. Find out the freezing point. But here the answer is in Kelvin. So you have to subtract delta TF from 273 Kelvin. Okay. Yes. So find out delta TF. Delta TF is equal to Kf into M. Delta TF is equal to Kf into M. Kf given molality. Molality you can calculate. Mass of solute given. Molar mass of solute known. Mass of solvent given. You can find out molality. Or substitute directly. You are getting delta TF. So the new freezing point of the solution will be freezing point of water minus delta TF. So this is the new freezing point of the solution, 270.85. Freezing point of water 273.15. Standard freezing point 273.15 minus 2.325 will take you to the answer option B, 270.83. Is it clear? Next. Value of Henry law constant. CO2, vinyl chloride, methane, formaldehyde are given. The solubility of these substances. I am sure you have learned the Henry's law statement and the concerned consequences. How does KH value influence the solubility? Higher the KH value, lower the solubility. Please refer the textbook. helium, hydrogen, etc. having very high KH value and they are least soluble. While formaldehyde, low KH value, highly soluble. It's as simple as that. So KH value and solubility are inversely related at a particular pressure. At a particular temperature pressure condition, KH value and solubility are inversely related, right? So which is having high KH value? 1670, 611, 413, 1.8. So the values are in the decreasing order. Therefore, the solubility will be in the increasing order. CO2 minimum, CO2 minimum, then vinyl chloride, then methane. So the answer is option A itself. CO2 has high KH value, so minimum solubility. Then vinyl chloride, then methane, and formaldehyde HCHO, CH2O having very low KH value and high solubility. Option A is the correct answer. Next. A solution was obtained by mixing 20 gram 20% solution and 200 gram 20% solution and 300 gram 30% solution. The mass percentage of solute in the resulting solution is, see, 200 gram 20% means, what is the mass of solute? 200 gram 20%, what is the mass of solute? Mass of solute is 20% of 200, that is 40 gram. Isn't it? Isn't it? 20 by 100 into 200, 40 gram. What is the mass of solute in the second case? It is 30% of 300, that is 90 gram. So mass of solute in the first case 30, 20, 40 gram. Mass of solute in the second case 90 gram. So what is the percentage after mixing? Percentage after mixing, it is 40 plus 90 divided by total mass of the solution 200 plus 300. So it is 130 by 500. That is the answer. 130 by 500. That is the answer. I mean mass fraction. Percentage means into 100. Percentage means into 100. This is mass fraction. So how much answer you are getting? Mass of solute from the first case, 20% of 200, 40, 30% of 300, 90. Total it is 130. And the mass of total solution, 500. So 130 by 500 into 100, you are getting 26%. 26%. Option C as the correct answer. A beautiful, simple question. Next. Molarity of solution containing 5 gram NaOH in 500 ml solution. Molarity of solution of 5 gram NaOH in 500 ml solution. 5 gram NaOH, 500 ml. Therefore, in 1000 ml, 10 gram. So, what is the molarity? 10 by 40. That is 1 by 4. 0.25 will be the answer. 0.25 will be the answer. Oh my God. Not option A. Not option A. Option C. 0.25 mole per liter. Option A. You see how the choice given so as to make us trapped. Listen to the unit. 0.25 if you are getting, don't simply jump on to option A. It is option C. Mole per liter. The unit also has to be taken care of. I think you understood how the calculation was done. You see, 5 gram in 500 ml solution. Therefore, 10 gram in 1 liter, 1000 ml. 10 gram in 1 liter. 10 gram means how many mole? 10 by NaOH, 40. That is 1 by 4. That is 0.25 mole per liter. That's all. All this to be done in the mind, not to write. 0.25 mole per liter. Okay. So that was the last question from the chapter solutions. So there we wind up the discussion of some important questions from the chapter solutions. We will meet with another chapter, another some good questions in the next class. Okay, bye. See you. Take care.